All right. Hi, folks, and good afternoon. Application security, what should the attack landscape look like in 2030? So how many of you have been following along the 2030 track? So not many. So people are more interested in security than 2030. That's good to know. And I'll kind of start by saying, I think I'm pretty good at determining what's going to happen in the future. And I saw evidence today that I'm actually terrible at predicting when things are going to happen in the future. So I saw this morning Amazon announcing their trusted platform module on Nitro, which is going to allow secure boot of virtual machines, which is something I did a talk about in 2007, thinking that that was going to be commonplace in about 2 or 3 years' time. And it took 15. So I hope that the things I'm going to talk about will actually be feasible and happening in 2030. But if it ends up being 2040, then don't be too surprised. All right, a brief introduction to me. So hi, I'm Chris Swan. I'm an engineer at the Act Company, and there we're building a platform that puts people in control of their data. So the thing there is we give everybody and everything a place to store data and control who has access to it. This talk is not about that. I'm co-host of the Tech Debt Burndown podcast. Season 1 of that we put out last year, myself and Nick Selby. Season 2 we're recording at the moment. We've got some great interviews with some fantastic people in the can, but it's been a bit slow getting stuff lined up, so I'm not quite certain when we're going to start putting those out yet. I've been a cloud editor at InfoQ since about 2014, writing about cloud and DevOps and sometimes security stuff. I've been blogging since 2008, started off talking a lot about identity, and these days, all sorts of random things. You can find the links to socials and all of that at chris.swans.net. And if you want to tweet about this talk while I'm doing it, I am at CPSwan. So what to expect? I'm going to start out telling the story of why I am talking about this, so how this talk came about. And in particular, what made me think that input validation was a problem, because I think it's one of the key problems we're now facing kind of in the general security ecosystem. There will then be cartoons and some hopefully amusing news headlines, and there will definitely be some XKCD. I'm then going to maybe take a sort of wild turn into why I think input validation is like porn, and how those two sort of share some problems in common, and how actually in the end that's not particularly helpful to us. And then kind of as I get towards the end of this, talk about developer experience, because I think developer experience is really at the heart of the problem that's being tackled here. And I'll take a brief look at how static analysis fits into that. And then ultimately, it's 2022. We're talking about what hopefully can happen by 2030. We can do better. And so what do we need to do better? And some concrete kind of actions that we as an industry, and hopefully we as a community, the people in this room, can start doing to actually start tackling this problem. So why am I talking about this? So this is Wendy Nather. I got to know Wendy when she was the lead of the security practice at 451 Research Group. Wendy's done all kinds of amazing things since. And these days, following the acquisition of Duo Security by Cisco, she heads up Cisco's Chief Information Security Officer, CISO advisory practice. And so Wendy was invited last year to do a talk to mark the 20th anniversary of the OWASP initiative. And she reached out to all of her pals in the industry with this question. She said, in the last 20 years, what's one of the most important things that you personally have learned about application security? And so this question landed in my DMs on Twitter one day. And this was my initial answer, just kind of going at it cold. My initial thought was kind of, what have we learned in 20 years? Well, approximately sod all, I felt. But I kind of tried to distill it into something sensible, and I said, input validation should be baked into languages and frameworks to make it stupid easy for developers to write safe apps, but it still isn't. So that's what happened in 20 years of OWASP for me. I gave it a little bit more thought and said this. My thinking here is that if there was a language, maybe likely a JavaScript derivative like TypeScript, that treated input as unsafe until it washed through a set of standard validators, then we could get to a place on input safety that we seem to have achieved with memory safety in Rust. The compiler would essentially support an input taint checker. And we'll come back to that towards the end. So the sort of TLDR of this, or the too long didn't watch, is what should the attack landscape look like in 2030? Well, injection vulnerabilities caused by poorly validated input should disappear from the OWASP top 10 like buffer overflows have. So I've talked a little bit about OWASP already, and I've just referenced the OWASP top 10. Who in the room's kind of already familiar with OWASP and the top 10? A smattering, but fewer than I expected, for an audience that seems to have declared itself security curious. Okay then, so what made me think that input validation was a problem? So my conjecture was that the OWASP top 10 has hardly changed. So the OWASP organization, the Open Web Application Security, and they've been publishing their list of top 10s since about 2003. And if we look back all the way to 2003 top 10, number one at the top of the list, they called unvalidated parameters. And when they revised that a year later, they renamed that as unvalidated input. So unvalidated input used to be right at the top of the top 10. And my conjecture was, actually, that's kind of hardly changed. So there's been some shuffling around with the top 10 over the years, but input validation, still a major problem. Now, if we look down the list a little bit, we get to number 5, buffer overflows. And buffer overflows used to be a massive issue. And if we look at sort of malware and some website attacks, buffer overflows were one of the most commonly exploited issues with the underlying software. But as we'll see, they've kind of gone away. And so there's a variety of things have happened in the industry to make buffer overflows go away. And so what would we have to do to make input validation go away? Well, part of what happened here is we started giving things more specific names. And so if we look at the top 10 as it kind of transitioned from 2013 to 2017, you can see there's a bit of shuffling going on here. But you can also see that there's a bit of relabeling happens as well. So by this point, we don't talk about the number one problem being input validation. We talk about the number one problem being injection, which is just a different name for input validation. You know, people are injecting stuff into websites, and how do they inject that? By input. So this is just a rename of the problem that's been the number one all along. And in fact, there was another reshuffle. So after Wendy had asked me the question, and I'm kind of sat there thinking, yeah, the OWASP top 10's kind of been the same for the best part of 20 years. They announced the 2021 OWASP top 10, and you can see on the right-hand side of the slide that actually there's been quite a big reshuffle going on there. So number one now is broken access control, and people exploiting that. And injection has actually slipped down to number 3. But it's still there, and it's still a really massive problem to be occupying the number 3 slot on the OWASP top 10. So as already mentioned, we're no longer talking about buffer overflows. And why is that? Well, here's the RedMonk top 20 for languages. RedMonk, if you're not familiar with them already, an analyst company really specializing on developers and how developers are using their tools, such as languages and frameworks. And they construct this top 20 by looking at the popularity of languages in GitHub and the popularity of questions about languages on Stack Overflow. And so if your favorite language is here, then yay. Good for you choosing one of the popular ones. And if it's not, then it's probably one of the up-and-comers, I would hope. So if we look at most of that top 20, with a couple of noticeable exceptions, these are languages now that, in one way or another, are memory safe. So they're either virtual machine languages, and so memory management is being taken care of by the virtual machine and the garbage collector, or they're languages that have got specific language constructs like Rust has, and I think Rust stands out here as a language that's kind of been created for systems programming to be done in a memory safe way. And so buffer overflows have kind of gone away because there's been a massive shift towards using these popular languages that are kind of out-of-the-box memory safe. And even if we look at the languages that aren't memory safe, and so C++ is still there in that top 20, sat there at the 7th spot, the people making use of C++ have kind of moved into development practices where they're doing other stuff to help them deal with the lack of safety in the language itself. And so buffer overflows have sort of been pushed out of the picture. So on now to the fun stuff. Let's get some cartoons and some headlines. Who's seen this one before? This is an almost infamous XKCD, making a joke about somebody who's put some SQL injection into the name of their child, and then the school phoning up and saying, I hope you're happy. They've destroyed the student database. And the whole point here is, the end panel, well, I hope you've learned to sanitize your inputs. So when we're kind of making fun of these things in popular culture, it's clearly well understood as a problem. And this is one of the really early XKCDs, so 327. It's kind of somewhat back in the midst of time now. So much so that people have taken inspiration from little Bobby tables and started to have a go at similar attacks in the wild. And so that company whose name used to contain HTML script tags limited originally had a company name which you can see there had a script tag in it, and that is a cross-site scripting attack. And that cross-site scripting attack actually worked inside of the company's house website that was listing out company names. And when this was discovered, Company's House asked the company to change their name. And they changed their name, as you see on the title, to that company whose name used to contain HTML script tags. So somebody was having a bit of a laugh here and was paying a company registration fee in order to prove a point. But for me, the point that it proves is that organizations, even sort of grown-up organizations like Company's House, haven't got a grip of this problem, and people are going to make fun of them in this case because of that. Now, this can, of course, be a lot more serious, and that's going to be some of the other headlines that I go to now. And Kevlin Henney's doing the closing keynote this afternoon. I'm very thankful to Kevlin for the next few, because he kind of keeps this archive of sort of IT tragedies in the news and the underlying causes of them. And so as I was preparing this talk, I reached out to Kevlin and kind of said, what have you got in your collection that relates to bad input validation? And he sent me a list. This isn't the whole lot, but it's my juicy picks from the list. So there are more. Really stupid smart contract bug let hackers steal $31 in digital coin. It used to be $31 million, but that was last week. Company says it's contacted the hacker in an attempt to recover the funds. That has occasionally actually worked. There's been some blockchain bro things where the community has been so intertwined that people have acted in good faith, but not so often. And another one, missing line of code leads to a 7.2 million exploit of the X-Burger swap. And this is another cryptocurrency-related one. But again, bad input validation. And there's a whole raft of these so-called smart contracts where it's kind of one bug there, and people then use it to exploit the contract against the underlying cryptocurrency, and fun and entertainment happens. And more. This one, I'm going to show you on the next slide, the actual form. So Citibank just got a $500 million lesson in the importance of UI design. So they were trying to make an interest payment on a loan and sent the wrong amount. And when you see the form, it's easy to see why they sent the wrong amount. What I'm wondering is how it took so long for somebody to mess up with this form, because that is just a user interface catastrophe. And I take one look at that, and it's a disaster waiting to happen. And so, yes, there was some poor input validation going on here, but I think that was probably a minor crime compared to this being used day in, day out for sending millions of dollars around. You've got to have really well-trained people to work with something as awful as that. And then we get into some of the semantic stuff, the butt of all the jokes. So the headline here is, life is hard on the internet when your last name is Butts. And it also refers to the Scunthorpe problem. Anybody come across the Scunthorpe problem before? Yeah, really awkward place to live when people are being just sort of brute force about how they do some of their input validation. And it's not just Butts. So Natalie Weiner found that her last name was considered to be offensive language. And so there's input validation happening here, but it's input validation that's not necessarily achieving the right thing. Now, clearly, there are companies, and particularly things like social networks, where they're trying to stop people from choosing offensive language to be their tag on the system or something like that. But it can cause collateral damage, and here is an example of that. So that gives me, I think, a really good segue into why I think input validation is like porn. And it comes to this statement of, I know it when I see it. And so this came from Justice Potter Stewart when he was sat on the Supreme Court. And the Supreme Court was ruling about pornography, and in particular, he was having to come up with a judgment about hardcore pornography. And ultimately, this statement that he made was what he became known for. So, an entire life as a lawyer and a judge, and eventually kind of reaching the pinnacle of that in US legal life, at least, being part of the Supreme Court. And this is what he's now known for. This is his legacy. I know it when I see it. And he said, I shall not today attempt to further to define the kinds of material I understand to be embraced within that shorthand description, hardcore pornography. And perhaps I should never succeed in intelligibly doing so. But I know it when I see it. And so I think we can take this same statement, I know it when I see it, and apply it to our input. So when we're thinking about what's good input, I know it when I see it. And I think the flip side of that coin as well, we can see things that are obviously taking the mickey and say, I know it when I see it, when we see those things as well. And what the justice was doing here was kind of tiptoeing around the fact that he didn't want to encode his definition of hardware pornography into the law, because once he started writing it down, that would give a concrete definition. And once there was a concrete definition there, people would start gaming that and working around it. And so he kind of deliberately left some room for interpretation there with, I know it when I see it. But I think we face many of the same problems developing software, because if we know it when we see it, how do we actually describe that in our programming language? And how much help are we being given by our programming language and accompanying frameworks in order to do that? So who thinks this looks okay for a piece of input? Anybody know what that is? This is the log4j, or log4j, I hear some people call it, attack that we all saw at the end of last year. And so the logging framework had within it some functionality where you could use external references through a Java directory lookup. So in this case, it's a Java directory lookup to an LDAP URL. And this, it turns out, can be exploited to get shell access to the underlying computers. And shell access to the underlying computers being driven through logs is really bad and has caused lots of misery to a great many people over the course of the last few months. And so the people constructing the framework did actually think that this was okay. They were adding functionality to make use of this. Somebody had come up with a use case, and this was the way to drive it, and it was all a very good idea. Now, I might argue that there wasn't much offensive mindset going on there, that as you add a feature to something, you should probably be thinking about how that feature is going to be perverted and exploited and used for nefarious purposes. And I don't think enough of that happened, but this is correct input for using that feature. And so it's okay. I think also they're facing an enormous problem with something like a logging framework. When we're asking people to type in their last name, it's fairly straightforward to come up with some parameters for what we think a last name should look like. And we might then start getting ourselves in trouble by saying that there are some last names that we don't want to have because they're rude or whatever. But it's a fairly tightly defined problem space. Whereas what is correct input for a logging framework? Well, I think everything is correct input for a logging framework, but as soon as your logging framework starts doing stuff to that input or behaving in a reactive way to what the input stream is doing, then you can potentially get into trouble. And this is a horrible example of it. So what about this? As soon as people realized that the attack was using JNDI, then they started using regexes to look for JNDI. And if JNDI was there, then you would kind of throw that piece of logging away and not accept it and not trigger the shell attack. And a game starts. So people then, in this case, it's not the JNDI, it's the LDAP, start using $L, $D, $P, and they're spelling out LDAP rather than having LDAP just there as 4 letters. So if we go back to I know it when I see it, then when I see something like this, I know it's probably nefarious. And so potentially one of the things we can do here is we can flatten input and compare the flattened input to the input. And if somebody is kind of doing some unflattening trick, that should be raising alarms. Similarly, this. So again, taking some of the characters we'd expect to find in an attack string and obfuscating those characters by using URL encoding. And again, if we flattened that down and compared it, we'd find that it's a mismatch and potentially somebody is having a go at our system here. And another one. So all of these were actually used as part of the game that developed to exploit Log4Shell. And this is a chart that accompanied a blog post from Cloudflare. And this is what they were observing on their web application firewalls over the course of time. So there's a certain amount of people using just JNDI, and then there's people using the lower attack, and then there's people using URL encoding, and then people then moved on to different ways of expressing it. What we see there is, in part, a sort of game theory thing going on between the attackers and the defenders. What we also see going on there as well, though, is people just keep banging away with certain attacks, whether they're working or not. And Bruce Schneier famously has this kind of statement of, the old attacks never go away. So people are coming up with new ways of exploiting your system, but there's always a sort of background radiation of they're banging away with the old attacks at you anyway. Web application firewalls, by the way, like the one that Cloudflare run as a service, are a great way of sort of bolting on validation after the fact. So Log4j wasn't doing the validation that we needed here, but you could put some rules into the web application firewall at the front end and hopefully screen out the attack vectors that were going to get into the logs. So input validation has a lot in common with content filtering, but this, it turns out, isn't actually particularly helpful. And so why do I say that? Well, I think we're maybe all aware of many failures with effective content filtering. So most social networks are doing content filtering to prevent indecent images from being uploaded and displayed. And because they can't police every single thing with sort of human sensors, then there's a huge amount of machine learning and artificial intelligence being thrown at that. But that then leads to a huge amount of false positives. And so, if we're taking, let's say, pictures of naked people, that will normally be keyed off skin tone. And so if a picture is judged to have too much skin tone, then that's getting a false positive. And so these same problems apply again to input validation. We saw the false positive of Reiner earlier on, and it's all part of the same problem. I'd go further to say that actually input validation is closely related to the halting problem. This cartoon here is based upon the somewhat infamous Ryan North dinosaurs panels. So he uses these same cartoon panels day in, day out, and just provides a different script to them. And this isn't actually from Ryan himself. This is somebody has taken it and written a script to go about the halting problem that the dinosaurs are telling each other. And if you go to the actual URL for this cartoon, it does run for 302 panels to try and make the point that if it goes past 300, then it must go on forever, except for it doesn't. So an example of the halting problem. And the halting problem starts talking about input. So for an arbitrary input, do we know if a system is going to halt or keep on looping forever? We don't. And so how are we actually understanding whether that input is valid input or not? These things are closely related. Okay, shifting gear a little bit then. Let's take a look at developer experience. I think the developer experience for doing input validation at the moment is something like the how to draw an owl meme. So we tell developers, do the easy bit, just draw 2 circles. First draw 2 circles, and then draw the rest of the damn owl. So here's our first draw 2 circles in JavaScript. So if I go to W3C School and ask how to do input validation, it shows me this. So I'm taking my input, and I'm doing an if to see if the input is null. And if it is null, I'm kind of raising my alert and returning false. So seems pretty straightforward, except that is only covering the most trivial of examples. And so I think that gets us to first draw 2 circles. It gets us nowhere near and now draw the rest of the owl. And so what help are we going to give to people to draw the rest of the owl? And what does drawing the rest of the owl look like? Well, like this. And I'm not going to read out all of that wall of text for you. That wall of text comes from the OWASP input validation cheat sheet. Highly recommended resource for this whole topic. And that is just the table of contents from that cheat sheet. So lots and lots of things that people are expected to be considering as they're doing their input validation. So I think it's a good thing that people have spent the time figuring this out and written it down in a document like the cheat sheet. But I think we can do better than that. As an aside, let's have a quick look at static analysis. So there are tools out there like semgrep, which will look at your code and help you identify problems with that code. So this particular example taken from their front page is looking for people leaving behind print statements in their Python code. And so in production, you probably want to be using a proper logging framework. And if you were doing Java logging, you might even use Log4j. And you can use a tool like semgrep to run through your code and see if the things that you're doing in your code kind of trigger different rules. And there's a whole set of open source rules come along with semgrep to either get you started or to help you develop your own rules to apply to that. A subset of the semgrep rules relate to input validation. And so that set of rules can be applied to code in a pretty wide variety of languages in order to identify when input is running through the code and potentially causing problems. And there's this notion here of a taint. And so when we capture raw input from a user, that's potentially bad. They could be trying to attack you. They might have a Bobby Tables attack in there, and that is tainted input. And so we can follow that taint through the code until it's been put through some kind of validation check, at which point it should be untainted and can then find its way into a database or a system of record or wherever the data is headed, where we hope that it's going to be clean. In addition to semgrep, which is open source, there's also a whole host of proprietary static analysis tools out there, which are mostly targeted at security. And if we go back to the buffer overflow issue, buffer overflows have mostly gone away, not just because people are using safer languages now, but the people using unsafe languages are actually using static analysis tools in addition to the language compiler itself. But if you look at the inner workings of a static analysis tool, it is essentially a compiler. And so this kind of leads to the question of, why am I using two compilers? Why can't my compiler do all of the work for me in one? Why can't my language or the frameworks that I'm using do that stuff for me? So this gets me to the sort of final point of, I think we can do better. I kind of hope we can do better by 2030 by making the tools that we use every day for developing applications help us more with input validation. So this is a picture of a yak, and I think we're probably all too familiar with having to shave yaks. But we don't want to be shaving yaks. It's unproductive work. And the yaks don't like being shaved anyway. So the ask here is to make validation a first-class part of the language. Pre-shave the yak, as the platform people say. And so if the platform folk can give us pre-shaved yaks, why can't we have some help with input validation as well? So we can do things like flattening. I was showing examples earlier of people messing around with JNDI. And if we offer flattening within the language, then we can see what the input is going to kind of arrive down at when it's making it into our system of record. And we can also make a judgment about whether input is good input. So if flattened input doesn't equal the input itself, that might be a signal that somebody is trying to cheat. We can throw exceptions for unexpected weirdness. So if we're expecting to see JNDI, but we're actually seeing wacky versions of people inputting stuff that looks like JNDI, then again, maybe I know it when I see it. When I see stuff at the bottom, that looks nefarious to me. And so throw an exception for that. So off the back of Wendy's question and the sort of dialogue that arrived from that, I put together this blog post. And it was titled, ValidScript, a modest proposal for app security. The link's at the bottom there. And the TLDR is there. Bad input validation is the main underlying cause of many application security issues because we haven't made it easy enough for developers to implement good input validation. So how about a TypeScript-like language to resolve that? ValidScript, a language that makes it easy to do input validation. I've done nothing about this yet other than the blog post and this talk. And so if people actually want to create this thing, please step forward and help. So there is, in addition to the blog post, a dormant for now GitHub organization. I went and registered some domains and put a GitHub organization in there. JavaScript is not my favorite thing at all. And so if other people want to run with this, I'm very happy to help and support and hand over various bits and bobs to do that. So it's time to wrap up. What have I talked about? I've talked about the fact that the OWASP 20th anniversary triggered this talk, that in 20 years of having an organization concerning itself with application security, not enough has changed. And so we've got rid of some problems, like buffer overflows, but input validation has lingered as a problem in the top 10, quite often occupying the top slot, presently at number 3. The cartoons and headlines show that the issue is well understood. There is no lack of understanding about this. But input validations like porn. It's kind of that whole question of I know it when I see it is actually difficult to resolve at a machine level. whether we're trying to do that with code or with fancier approaches like machine learning and artificial intelligence. Ultimately, the problem here is that the developer experience is terrible. The languages and frameworks that we use at the moment do not help us with input validation. The attitude of the industry has been, it's your input, you know what it should look like, you write the if then else type of expressions to deal with it. No help offered. That's just not how we do things for everything else these days. I mean, we've got frameworks for database access, frameworks for front end, frameworks for everything. Why are we not helping developers more with this? Static analysis can help, but it seems at the moment to be only used by the sophisticated practitioners. So in summary, we can do better. We can make developer experience easier for all. And I think that's what needs to happen by 2030 to change the attack landscape for applications. Thank you for listening, and I'll take questions. Come on, there's got to be some questions after that. What language should I start with?
Thanks for the talk. I have a question about, quite specific, about some of the XML vulnerabilities. I recently ran into a situation where I was passing some XML, and I had unwittingly, because the defaults are to have all of the horrible vulnerabilities like external entities turned on, because they have to be turned on by default for it to be compliant. Do you think that there's any chance that we can get those standards changed so that every XML parser in Java doesn't have vulnerabilities built in?
At this stage, no. I kind of lived through the XML years and the use of XML web services, and I feel like the industry as a whole has kind of given up and moved on from XML. So sort of since leaving that mid-noughts enterprise Java world, I've not much seen XML as a concern because people have started using JSON and YAML and these other serialization mechanisms. If you look at the fundamental problem of XML, it's that it's very cheap to produce. So you kind of take data and throw angle brackets around it. And very expensive to consume because you then have to do schema validation, and you've got concerns about the external entity attacks and the things that you described there, which is completely the wrong asymmetry. And so when we think about most computing, it's okay for things to be expensive to create if we can do them server-side. If it makes them then inexpensive to consume on an end device, whether that is the phones and watches and tablets and whatever that we all carry around with us, or whether it's a thing with maybe a lightweight microcontroller in it. And so it seems to me that XML was fundamentally the wrong way to go. And so the industry's kind of given up and moved on. And that has then drawn all attention away from fixing the ills of XML and the associated ecosystems. So things like those external entity problems still sort of linger for that reason. And of course, there then became a whole industry in XML security. So people providing sort of XML security appliances, whether as physical boxes or as software things, in order to deal with that. And that's the bolt-on again, like the WAF. I also sort of saw that this created a paradox. So when you talk to security people, they'll say it's always better to build in than to bolt on. And I once had an engineering team coming along and saying, well, we want to build in our XML security. There's a Microsoft guide for that. We'll just implement the stuff in the guide. And the problem with that becomes auditability. It's really hard for a risk team to actually audit code and understand that it's in compliance with a guide like that. Whereas if there's an XML appliance, they can kind of first know that it's there, and secondly, take a look at its config and have some confidence that that's been audited and is doing its job. So, yeah, I don't think there's a silver bullet for the problem you're asking about. And I think the appliances have become the answer, but it's not a good one because those appliances aren't cheap. And I've regularly seen what I describe as the restaurant problem in enterprises trying to deal with that, which is the first application that needs an appliance needs to spend $250,000 on appliances just so that the enterprise can have them. But there's no budget for that. And so they end up just then looking around for other approaches. So yes, it's a mess, and it's a subtly different mess from the input validation mess. And I think not one that we're going to be able to kind of have a go at by making sort of languages better fitted to input validation, because we had our shot at doing that with XML kind of in the mid-noughts, and I don't think things have improved. So looking ahead to 2030, do I think that'll be solved? No, because it's stayed unsolved now for best part of 15, 20 years. Another one here.
Can I ask, is there some example inputs which we could use by testing the application? So when we write a unit test, for example, or some test, that if we would have examples, what possible attacks, how do the possible attacks look like? It would help us to just take it and just test the input if it goes, if it validates or not.
Yeah, I think the clearest example of what you're describing is when people use fuzzers as part of their testing. And so for people that aren't familiar with that term, a fuzzer is a tool that's going to deliberately generate a wide variety of input to something. And so you might have seen the meme jokes online of a tester walks into a bar and kind of doesn't order a beer, they order -1 beers and affinity beers and 65,536 beers and stuff like this. So there's all kinds of input that we kind of know causes trouble. And fuzzers are tools that we can use to deliberately generate that troublesome input and make it part of a unit test suite. So we can then see how the application is behaving as a result of that input and see when it kind of goes off track. So yeah, I talked about static analysis. Fuzzers are, I think, another tool that we've got in the belt that we can make part of our overall development pipeline in order to help deal with the sort of broader problem of input validation. So yes, thanks for bringing that one up. Anybody else? A couple of minutes left, so time for one more if we've got them. No takers, it seems. All right, well, thank you very much.